For this problem, or these problems, we're going to simplify assuming all variables are positive. In the first example, we have x to the 1/5 divided by x to the 1/4. In the second example, we have x to the 1/3 divided by x to the 5/7. We're going to go through the first example, and then I suggest that you pause the video at the end of it and try the second example on your own, and then I will go through it. To start this off, whenever you're dividing two numbers that have the same base, so two values with exponents, since they both have the same base, this x value, then all we have to do is subtract the exponents. Whenever you're multiplying with the same base, you add the exponents. Dividing, you subtract. So in this case, we're going to keep that x that's common between the top and bottom of this fraction. And we're going to take the top's exponent, so 1/5, and we're going to subtract the bottom exponent, which is 1/4. When we do that, we're subtracting fractions with different denominators, which means we need to find a least common denominator. And the least common denominator in this case is the number that 5 and 4 both divide into evenly, the smallest number that is, and the smallest number that 5 and 4 both divide into evenly is 20. So we need to rewrite each of these fractions with a denominator of 20. So let's go ahead and do that off to the side. We have 1/5 minus 1/4. We need to change this 5 and this 4 to 20. So to change the 5 to a 20, we have to multiply it by 4. And when we multiply that 4 to the bottom, we also have to multiply it to the top so that we don't change the fraction or change the problem. And then likewise, to get this 4 to become a 20, we have to multiply it by 5. And we have to do the same thing to the top, which gives us 4 over 20 minus 5 over 20. And when we simplify this, we're going to keep the denominator, since we have the same denominator between our fractions and we're adding or subtracting. We just keep one of the denominators and we add or subtract the numerators. So we have 4 minus 5 all over 20, which gives us negative 1/20. So now x to the 1/5 minus 1/4 is the same thing as x to the negative 1 over 20. And from there, we cannot leave a negative in our exponent, otherwise it will not be simplified. So we're going to move this value to the denominator. Remember, whenever you have any whole number, you can put it over 1 and you still have the exact same problem. So to make this exponent positive, we will move this down to the denominator, which gives us a positive exponent. We have 1 over x to the positive 1/20. And that is the completely simplified form of x to the 1/5 divided by x to the 1/4. Okay, now I suggest you pause the video and try part 2 on your own. Okay, so now let's try this together. Repeating exactly what we did in the last problem, our first step is to take our common base from the numerator and denominator, which is this x, and we're going to subtract the bottom exponent from the top exponent. That gives us x to the 1/3 minus 5/7. And again, we need a common denominator to subtract these, so we have 1/3 minus 5/7. The least common denominator between 3 and 7 is 21. So we're going to multiply this 3 by 7 to get that 21 in the denominator of this fraction. And when we multiply the denominator by 7, we also have to multiply the numerator by 7. And now we'll repeat the same thing over here. To get this 7 to become a 21, we have to multiply it by 3, which we also multiply to the numerator so that the problem is unchanged. That gives us 7 over 21 minus 15 over 21. And now to subtract these fractions, we get 7 minus 15 all over 21, which gives us negative 8/21. So x to the 1/3 minus 5/7 is x to the negative 8 over 21. And now again, because we have a negative in our exponent, we have to put this entire thing over 1 and move this value that's being raised to a negative exponent to the denominator to make it a positive exponent. So that gives us 1 over x to the 8 over 21. And just one more side note, as this can be a confusing part right here where this 1 came from. Just a quick note, if we had gotten to this step and say the problem was 2x to the negative 8 over 21, then when we put this over 1 and move the x to the denominator, because the 2 is not included with that negative exponent, then we would be left with 2 over x to the positive 8 over 21. So whatever number is being multiplied to your x in this case is the number that stays in the numerator. So in both of the examples we did, there was a 1 being multiplied to each of our x values. Since there was nothing in front of them, there's technically a 1 there, which is why we were left with a 1 in the numerator of each of our final answers.